In the previous class, we have discussed Augmented Dickey Fuller test. In the Augmented Dickey Fuller test procedure, we have tested for only one unit root. This is because the model used in the context of Augmented Dickey Fuller test is an AR1 model. For an AR1 model, there is only one root in the lag polynomial. This root may be 1 or less than 1. If it is 1, we have the unit root problem, non-stationarity. If it is less than 1, if the root is greater than 1, the process is stationary. But we have also discussed that if we have a process generated by AR2, the lag polynomial is 1 minus phi 1 L minus phi 2 L square, and the roots are obtained by the equation equal to 0, and we will have two roots, L star 1 and L star 2. So if a model is generated by AR2, AR3, etc., we have to test for more than one unit root. If it is generated by an AR1, we test for one unit root only. But there are some cases in which the time series will be stationary, integrated of order to I2. Even though most of the time series is I1, occasionally you will encounter I2 integrated of order 2 time series. As an example, it has been observed that nominal price series if expressed in log terms is, consider the price series log PT. PT is the price series. Now you take the first difference, del D log PT is equal to T log PT is equal to log PT minus log PT minus 1 is equal to PT minus 1 by PT minus 1. If you multiply this with 100, you will get the rate of inflation. The rate of inflation. So if you have a price series like a consumer price index, wholesale price index, or implicit GDP deflator, etc., and if the series is expressed in log terms, its first difference is nothing but inflation rate, and inflation rate in most cases will be I1. Inflation rate, that is the first difference of PT, log PT, is in most cases I1 series. So an I2 series appears smooth and slowly changing than I1 series. Smooth and slowly changing than an I1 series. So, and a log transformed I2 series may generate I1 growth rates. So the point is, if there is a shock to the series in level, the shock will persist in the series in first difference also. That means the first difference is also stochastically trended, or the stochastic trend will not be eliminated with the first difference. Now if this is the pattern, testing for one unit root is not appropriate. And if you mistakenly believe that the process is I1, and if you use the first difference, that is delta log Pt, it will give you misleading results. It will give you misleading results. So in such cases, we have to test for 2 unit roots or more than 1 unit roots. If the process is generated by ARP, there will be P roots, but there will not be more than 2 unit roots because the maximum which we expect is 2 unit roots. And in most cases, there will be only 1 unit roots. So, what is the strategy? If you suspect that the process has 2 unit roots. Now, there are 2 strategies to test for 2 unit roots. 2 strategies if you suspect that the time series is integrated of order 2. One is test directly for the existence of 2 unit roots. Test directly for the existence of 2 unit roots. This is suggested by Hassa and Fuller, 1979. For example, in the first example we have considered, test the hypothesis that phi1 is equal to 2, phi2 is equal to -1. While discussing unit roots, in the first example, if phi1 was 2, phi2 was -1, the 2 roots were 1, 1. So we have 2 unit roots, and as we have discussed earlier, we have to first difference the series 2 times to make the series stationary. So this is one approach if you suspect that the process has 2 unit roots. This is suggested by Hassa and Fuller in 1979 and tested against the alternative that these restrictions not valid. These restrictions not valid. So this is one procedure. Even though this procedure has its own merits, a simple alternative is available. And in the softwares, this alternative strategy is given. And it is a sequential procedure. The alternative is a sequential procedure suggested by 2 econometricians, Dickey and Pandula. Dickey and Pandula in 1987. Sequential procedure suggested by Dickey and Pandula in 1987. The procedure is you start with the highest degree of differencing. Start with the highest degree of differencing and work downwards a test on the series in level. You start with the highest degree of differencing and work downwards to the level of the series. To explain this procedure, suppose that we want to test for 2 unit roots. We want to test for 2 unit roots. We want to test for 2 unit roots. And first step is define ZT as equal to delta YT. First difference ZT. And when we take and we test for, we use the sequence ZD to test. The logic behind this procedure is, when we take the first difference, we impose 1 unit root When we take the first difference, we impose one unit root on the original series yt. And this procedure in effect is assessing whether a second unit root exists conditional on the existence of one unit root. You are testing for one unit root in delta yt. And when you test for one unit root in delta yt, it is based on the assumption that there is one unit root in yt, or on the condition that there is one unit root in yt. So, suppose that this null hypothesis is accepted. That is, we test for one unit root in zt, and suppose that this null hypothesis is accepted. Then we have two unit roots in the original series. So instead of testing for one unit root in yt, we test for one unit root in delta yt. This is based on the assumption that there was a unit root in yt. And if this null hypothesis is accepted, we have two unit roots. And if this null hypothesis is rejected, then it follows that there is only one unit root. Now, if you want to test for three unit roots, it will not be necessary in most cases. Then you test for one unit root in wt. Wt is equal to delta zdt is equal to delta yt. You are testing for one unit root in wt, imposing one unit root in delta zdt, imposing one unit root in zdt and one unit root in yt. That is, one unit root here, one unit root on zdt, one unit root on zdt, yt. If this null hypothesis is accepted, we conclude that there are three unit roots. If rejected, two unit roots. If rejected, one unit root, like that. So this is the sequential procedure. This is the sequential procedure. Now, let us see what are the maintained regression for testing this. Testing for one unit root, two unit root, etc. Now, if you are testing for two unit roots, then the maintained regression is delta zdt, because we are testing on zdt. So delta y, for testing this we use delta yt. So delta zdt is equal to we can have three forms: gamma zt minus 1 plus sigma alpha j delta zt minus j is equal to 1 to p plus epsilon t, one model. Then delta zt is equal to mu plus gamma zt minus 1 plus sigma alpha j is equal to 1 to p delta zt minus j plus epsilon t. Then delta zt is equal to mu plus gamma zt minus 1 plus sigma alpha j delta zt minus j plus beta t plus epsilon t. J is equal to 1 to p. We have three models as usual, but the testing is not on yt, the testing is on zdt. If you suspect two unit roots, if you suspect three unit roots, it becomes delta wt summa. So delta is wt equals like that. And remember this point also, in the eViews software, you have an option to test these three forms, and also an option to test for unit root in level, first difference and also second difference. All these are available in augmented form. So you need not worry about how to implement this. Software will help you. What is required from you is you will be aware of, sure about which model you are testing. And that is all about augmented Dickey Fuller tests.